Hello, everyone, and welcome to The Explainer. I am absolutely thrilled you're joining us today because, well, we're tackling one of the most fascinating, rapidly evolving, and frankly, heavily misunderstood technologies of our entire era, machine learning. We hear this buzzword literally everywhere right now, from our smartphones to the nightly news, but what actually is it? How does it work behind the screen? Well, today, we're going to break it all down into clear, easy-to-understand steps. Okay, let's dive into this.
So, here's our roadmap for today. We're going to start by defining what machine learning actually is and how data predicts choices. Then we'll explore 3 specific ways machines learn. Test your knowledge with a quick quiz, see why this tech is exploding right this very second, and finally, look at everyday applications. It's a nice, structured path, and by the end of it, you'll have a crystal clear understanding of this whole ecosystem. All right, let's start right at the foundation with Section 1, what is machine learning?
Traditionally, we all know how humans learn, right? We learn from past experiences. You touch a hot stove, you get burned, you learn pretty quickly not to touch it again. Machines, on the other hand, historically just followed strict, pre-programmed instructions given to them by humans. They only did exactly what we told them to do. But recently, that paradigm shifted entirely. What if humans could train machines to learn from past data, do what humans do, but do it infinitely faster? That is machine learning. It's way more than just rote memorization. It's about training machines to understand context, to reason through complex problems, and to process massive amounts of past data to make incredibly accurate decisions for the future.
To truly grasp this, let's jump into Section 2, predicting choices with data. So, I want to introduce you to a guy named Paul. Paul loves discovering new music, and he basically either likes a song or he dislikes it. He judges a song based on a few factors, but for simplicity's sake, let's just look at 2. Tempo, ranging from relaxed to fast, and intensity, ranging from light to soaring. Let's say Paul's past choices show us he absolutely loves fast, soaring music, and he hates slow, light music. If he listens to song A, which has a fast tempo and soaring intensity, well, we can easily guess he'll like it. It's obvious. But look at the second example. Song B has a medium tempo and medium intensity. It's stuck right in the middle. Will Paul like it? It's kind of a mystery to a human observer. And this brilliantly illustrates exactly where machine learning comes in. When human choices become complicated, algorithms step up to the plate. So, how does the machine solve the mystery of song B? Well, it uses a pretty basic machine learning algorithm called k-nearest neighbors. Imagine plotting all of Paul's past song choices out on a big graph. The machine simply draws a circle around our mystery song B to look at the songs that are plotted closest to it. If within that circle there are 4 past songs Paul liked and only 1 he disliked, the machine simply takes a majority vote. 4-1. The model confidently predicts Paul will definitely like song B. It's actually a surprisingly simple, elegant way to predict complex choices using past data. Okay, let's move along to Section 3, 3 ways machines learn. The golden rule here is, the more data the machine has, the better the prediction model gets, and the higher the accuracy of its guesses. But how exactly do these prediction models absorb all that data? There isn't just one single way to teach a machine. Depending on the kind of data you're working with, data scientists use 3 primary methods: supervised learning, unsupervised learning, and reinforcement learning. Let's break these big 3 down one by one so you can see exactly how they differ. First up, we have supervised learning. Imagine a friend gives you 1,000,000 coins made up of rupees, euros, and dirhams. Now, each currency has a specific weight. A rupee is 3 grams, a euro is 7 grams, and a dirham is 4 grams. In machine learning terms, that weight is what we call the feature, and the currency name is the label. If you feed this clearly labeled data into the machine, it learns the exact association: 3 grams equals a rupee. So when you hand it a brand new, never-before-seen 3-gram coin, it confidently predicts rupee because it was supervised and trained with all the answers in advance. Now contrast that with unsupervised learning. This involves giving the machine totally unlabeled data. You aren't giving it the answers up front at all. Instead, you just dump raw information into the system and effectively force the machine to sift through it and identify hidden structures, groupings, or patterns entirely on its own. Let's look at how unsupervised learning works in practice using these cricket players. We feed the machine raw data, runs scored on the y-axis, and wickets taken on the x-axis. Notice we do not tell the machine who is a batsman and who is a bowler. Now, what's really interesting about this slide is how the machine processes the data and notices 2 distinct clusters. One group scores high runs but takes few wickets. The other scores low runs but takes many wickets. Without any human labeling whatsoever, the machine automatically separates the players into batsmen and bowlers based purely on their performance patterns. The third method is reinforcement learning. Honestly, think of this kind of like training a puppy using a reward and penalty system. It works completely on the principle of continuous feedback. If you show the machine a picture of a dog and it guesses cat, you give the system negative feedback. The machine registers that its prediction pathway was wrong, it adjusts its internal parameters, and it learns from that exact penalty. So the next time it sees a similar image, it's going to classify it correctly as a dog. To generalize this entire ecosystem, this simple flowchart basically represents the heartbeat of machine learning. Step 1. Input data is given to the model. Step 2. The chosen algorithm processes it. Step 3. It spits out an output result. And Step 4. If the result happens to be wrong, feedback is routed right back into the model to train it further. It loops and loops, constantly refining itself until the output is consistently, perfectly accurate. All right, let's have a little fun and jump into Section 4, putting models to the test. We've covered a lot of ground so far. You know the difference between feeding a machine labeled data versus letting it find hidden patterns all on its own. So I'm going to give you 3 quick real-world scenarios, and I want you to actively guess if they use supervised or unsupervised learning. Ready? Let's do it. Scenario 1. You upload a photo to Facebook, and it instantly suggests tagging your friend Sarah. Does this use supervised or unsupervised learning? Take a second. If you guessed supervised learning, you are absolutely correct. By manually tagging Sarah in dozens of previous photos, you provided the machine with heavily labeled data. The features were her facial structure, and the label was her name. Okay, scenario 2. Netflix recommends a gritty crime documentary to you on a Friday night based on your past viewing history. Supervised or unsupervised? Think about it for a second. The primary driver here is unsupervised learning. Netflix clusters your specific viewing habits with millions of other users who happen to watch similar things. It isn't necessarily labeling you, it's finding hidden behavioral patterns to group you with similar viewers and suggest what they liked.
Final one. Scenario 3. Your bank automatically flags a weird credit card purchase made in another country as suspicious. Which learning method is this? Yep, this is largely unsupervised learning, specifically a subset called anomaly detection. The machine learns the normal pattern of your everyday spending. When a transaction occurs completely outside that normal clustered pattern, it flags it as an anomaly. Great job applying these concepts, by the way.
Moving right along to Section 5, why machine learning now? Now, you might be wondering, the theories behind these algorithms have actually been around for decades. So why is this massive technological explosion happening right now in this specific era? Why didn't this happen back in the 1990s? Well, the answer is basically twofold. First, humongous data. Millions of data points are generated every single minute by our online transactions, smartphone usage, and just everyday internet surfing. Data is literally the fuel for machine learning. Second, modern computers finally have the massive memory handling capabilities and immense computational power required to process this absolute mountain of data instantly without delay. We finally have the fuel and the engine at the exact same time.
Let's move to and see how this builds into our final segment, Section 6, Everyday Real-World Applications.
Because you see, this isn't just abstract theory, sitting in some university computer science lab. These algorithms are actively shaping the world around you, optimizing massive industries, and making decisions that impact your daily life. Just look at the sheer scale of its versatility. In healthcare, machine learning algorithms process medical imaging to predict diagnostics, highlighting areas for a doctor's review. Tech giants use sentiment analysis on social media to gauge the public mood. The finance sector relies heavily on it for the fraud detection we just discussed, and e-commerce sites use it to predict customer churn, identifying exactly when a shopper is about to abandon their cart or cancel a subscription so they can quickly send over a timely discount code. And here's an example I'm sure we have almost all experienced: Uber surge pricing. Have you ever tried booking a cab in terrible weather or during a crazy rush hour and seen the fare just completely skyrocket? That is a highly sophisticated machine learning model at work. It uses differential, real-time pricing and predictive modeling to anticipate exactly where demand will be the highest. By raising prices, it incentivizes more drivers to head to that specific area, ensuring that those who absolutely need a cab can get one, while continually working to minimize that surge pricing by perfectly balancing supply and demand.
Or simply look at the digital assistants we literally carry in our pockets. Every time you say, "Hey Siri, remind me to book a cab at 6 p.m., you are interacting with complex natural language processing, which is a massive subset of machine learning. It has to understand your voice, interpret your actual intent, extract the specific time, and set the action, all in a fraction of a second. It is truly remarkable technology that we kind of just take for granted now.
We've gone from the basic differences between human and machine logic to the depths of clustering algorithms and all the way to the surge pricing right there on your phone. So, I want to leave you with this provocative thought.
Take a close look at the apps on your phone, the targeted ads you see, the digital services you use. What interesting everyday examples of machines learning are around you right now, secretly pulling the strings and predicting your very next move? Keep your eyes open out there, and thank you so much for exploring with us on this explainer.